Namaskar everyone. I hope all of you are doing fine. So, uh, this is the third and last lecture actually in this series called Calculus for Physics. Today we'll see the homework problems that were given in the last lecture and also integral calculus. And with that we'll close this series, and after that we'll start with the chapter Motion in a Straight Line, chapter 3 of class 11. Okay. So the homework problems, let's do that first and then we'll see integral calculus. So what was question number 1? There was ddx of 18x to the power 7 log x. Okay, this is of the pattern uv, ddx of uv. You can consider u as 18x to the power 7 can be considered as u, and log x is v. So u ddx of v, u ddx of v plus v ddx of u is what you have. Now these are all natural logs. Okay, natural log is written with a base e, and common log is written with a base 10. We'll deal that separately. Logarithm will be dealt separately. Now ddx of log x is 1 by x plus ddx of 18x to the power 7. So you have 18 is a constant. So ddx of x to the power 7, 7x to the power 6. Okay, so 18x to the power 6 plus, here you have 18 into 7 is 126. Okay, that will get you 126 x to the power 6 and log x base e. So that's your answer. Question number 2. You can pause the video and go through again in case you have a confusion. Question number 2, ddx of x cube by log x. This is of the division form. X cube is u and log x is v. So what was the formula? V ddx of u minus u ddx of v divided by v square. So log x ddx of x cube minus x cube ddx of log x divided by log x whole square. Okay. Now these all are natural log. So you put a base, base e. So log x base e into ddx of x cube is 3x square minus x cube ddx of log x is 1 by x divided by log square x base e. So what you have is 3x square log x base e minus x square. And you see if there is a scope to take something common in the numerator. So what can be taken common in the numerator? It's x square, right? So 3 log x base e minus 1, and you have log x base e whole square in the denominator. That's your answer for the second problem. Question number 3, ddx of 5x cube e to the power x. 5x cube is u, e to the power x is v. So 5x cube ddx of e to the power x plus e to the power x ddx of 5x cube. Look, you have to continuously cross-check with the formula which I am reading out. Okay, you have to cross-check with your chart or with the formula copy that you have prepared. In that manner, you will recall these formulas for a long time. Otherwise, you'll forget them. So the formula for ddx of uv is u ddx of v plus v ddx of u. That's what we have written. So 5x cube ddx of e to the power x is e to the power x, right? Now ddx of 5x cube will get you 5 into 3x square. So what can be taken common from both these expressions or both these quantities? 5x square e to the power x can be taken common, right? What remains inside is x plus 3, right? X plus 3 is what is left behind. So your answer is 5x square e to the power x into x plus 3. Now we have the u form. Number 1, ddx of log ax plus b. Again, this is natural log. Okay, so ddx of log u, ddx of log u is 1 by u. Again, ddx of u. So here your u is a plus b. Okay, a plus b is u. So you have 1 by ax plus b it is. Okay, 1 by ax plus b is u. So you have 1 by u and ddx of ax plus b again, ddx of u. So 1 by ax plus b. Now ddx of ax plus b will get you a. Okay, so your answer is a by ax plus b. In the side note, I am showing that ddx of ax plus b. So this is a ddx of x plus ddx of b is 0, right? So a into 1 plus 0, and your answer is a here. So I hope this is clear. Question number 2. ddx of log 4 by x. And the base is e. Yes, it's a natural log. So ddx of log u is 1 by u. Okay, and again ddx of u. So this gives you x by 4 and ddx of 4 ddx of x to the power minus 1. Okay, so you have 4 cancels, x and ddx of x to the power minus 1, n x to the power n minus 1. So minus x to the power minus 2, that is minus x divided by x square. So your answer is minus 1 by x. Now this question number 3 is a lengthy one. Okay, those of you have mathematics as a main paper, like aspiring for JEE, you need to, anyway you will be doing this kind of sums in class 12. Okay, for physics you don't require that much, but for a collective understanding, I have, like, merged all the questions that we have done so far. Okay, so if you do this one single problem, like, your understanding is good, that can be understood. Okay, you can be sure that you have developed a good expertise on differentiation, or the u form, you can say. So 4y cube plus 10z square plus log of sin x plus e to the power cos x. So that equals 4 ddx of y cube plus ddx of 10z square, right? Plus ddx of log of sin x plus ddx of e to the power cos x. So you have 4 ddx of y cube is 3y square, again ddx of y. Okay, because y is u here, u form. You know, to look in the formula for ddx of u to the power n plus ddx of 10u is sec square u ddx of u again. So sec square z square, again ddx of z square. All right. ddx of log u is 1 by u. So u is sin x here. So ddx of log u, log sin x, will get you 1 by sin x. Again ddx of sin x plus ddx of e to the power u will get you e to the power u ddx of u. So e to the power cos x, again ddx of cos x. 12y square ddx of y. Okay, ddx of y plus Well, I am skipping a step here. Like ddx of z square will get you what? ddx of z square will get you 2z ddx of z again, right? I'm getting the 2z before sec square z square. So 2z sec square z square again ddx of z. If you don't understand this particular step, you can include one more step in between. Plus 1 by sin x, and ddx of sin x is cos x, plus e to the power cos x, and ddx of cos x is minus sin x. Okay, so 12y square ddx of y plus 2z sec square z square ddx of z plus cos x by sin x is cot x, right? Minus sin x e to the power cos x. Okay, that's your answer. Okay, next question. Number 4, ddx of cosec x square. So ddx of cosec u is minus cosec u cot u ddx of u again. So minus cosec u cot u ddx of u again. Okay, so ddx of x square will get you what? ddx of x square will get you 2x. So I'm writing that in the beginning. Then cosec square x square, sorry, it will be cosec x square, right? And cot x square, because minus cosec x cot x or minus cosec u cot u was the formula. So this is your answer. Question number 5, ddx of cosec y square. So in the previous question we had cosec x square, and now we are replacing x square with y square. Look, now y square is u here. Okay, so minus cosec u cot u, first of all, cosec u cot u, right? Again ddx of u. So ddx of y square will get you 2y ddx of y. So I'm getting that 2y in the beginning. So cosec y square cot y square and dy by dx or ddx of y. Okay, that's your answer. We have definite integral next. Sorry, not definite integral, it's just integral calculus next, or integration I'm writing here. I'll copy the formulas so that you can, although I provided them in the first class. So you have it here. You can go through the right section, the integral calculus formula. So question number 1, we can move to question number 1. Integral x cube dx. So integral x to the power n dx is the formula, right? X to the power n plus 1 divided by n plus 1. So we have, see, if you see in the chart, if I show you that in the chart, this is the formula. Now we don't write plus c. Okay, plus c will be used while doing mathematics. In mathematics, you use that c is constant. In physics, we mostly don't use that. Okay. So integral x cube dx will get you x to the power 3 plus 1 divided by 3 plus 1. So there is x to the power 4 divided by 4. That's your answer. Number 2, integral x square plus 1 by x dx. So integral x squared dx plus integral 1 by x dx. So integral x squared dx will get you x cubed by 3, right? Plus integral 1 by x dx is log x by z, right? Integral 1 by x dx is log x. So this is your answer. Question number 3. Integral x minus 1 by x whole square dx. Same minus b whole square. You have to break it at first. So x square plus 1 by x square minus twice a b dx. So you see x cancels here. So you have integral x square dx plus integral x to the power minus 2 dx minus 2 integral dx. So the first quantity, the first integral will get you x cubed by 3 plus integral x to the power minus 2 plus 1 by minus 2 plus 1, right? So that will get you x to the power minus 1 by minus 1 minus 2x. What is integral dx? Integral dx is x, right? So 2 integral dx will get you 2x. X cubed by 3. Now this minus comes here and x to the power minus 1 is 1 by x, right? Minus 2x. This is your result. Number 4. Okay, we don't have any number 4 here. We'll see definite integrals. This will suffice. You don't have to worry. Whatever we have done, this will help you. This will solve your problems. So we have definite integrals now. You can what's wrong? Okay, I have to copy this part only, the definition. So a definite integral has a start and end values. Okay, there is an interval AB. A and B are called limits or boundaries, and they are put at the bottom and the top of the integral sign. So this is the definition. So we have question number 1. This is a calculation, or this is a derivation from chapter number 8, gravitation, class 11. Okay. So here, this is the expression for universal. Sorry, this is the expression for gravitational potential energy. Okay, the expression comes out to be minus gmm by r, where g is the universal gravitational constant, m is the mass, small m is also the mass. This will be the masses of two bodies, say Earth and a different body, okay, away from the surface of the Earth, and x will be the distance. So the first question, integral x equal to infinity to x equal to r, and the expression is gmm by x square dx. So since gmm is constant, you can take them common and you can write down this. You need not write x equal to always. You can straightway write down integral infinity to r, and 1 by x square will get you x to the power minus 2, right? So gmm by, sorry, it's gmm, and integral x to the power minus 2 is x to the power minus 2 plus 1 divided by minus 2 plus 1, and the limits are placed here. Still we haven't used the limits, okay? So gmm and x to the power minus 1 by minus 1. Now in the next step we'll be using, okay, in the second next step we'll be using the limits. So minus gmm, and here you have 1 by x. Now you see the limits are always used in place of the variable, okay, and the rule is like upper limit minus lower limit. Okay, it's never lower limit minus upper limit. It happens under a situation when you have a minus sign inside, but here also we had that, but we took the minus sign outside. So initially you may start with this, okay. So 1 by r upper limit minus 1 by infinity. Look, we have we have we put the value of upper limit and lower limit in place of this x. So once you place the value of upper limit, then subtraction, again you place the value of lower limit. Okay, this is how you do. So what is the value of 1 by infinity? It is 0, right? So the second term goes 0 minus gmm by r is what remains. So that's your answer. Question number 2. Integral 0 to pi by 2, and you have cos x dx. So integral cos x dx is sin x, right? Now the limits will be written here. So you get sin pi by 2 minus sin 0 degree. So what is the value of sin pi by 2? It is 1, and sin 0 is 0. So you have 1 minus 0 is 1. That's the answer. Now some homework sums. I'll be providing the solution here itself, but after going through the questions, try solving them yourself. Pause the video and try solving them yourself. And after trying, then only go through the solutions. Okay, since I want to close this video today itself, I will not extend it. This homework solutions will not be extended in the next video. So question number 1, integral of x to the power 7 dx. That is x to the power 8 by 8, right? I'm writing directly. I hope you'll understand. Next, integral of x minus half whole square dx. So first you need to break this a minus b whole square, which is a square plus b square minus 2ab. Now you see this 2 cancels. So what you have is integral. Oh, sorry. I'm straightway doing the solution. Okay, let me complete this. The remaining sums I'll put as homework. These are actually homework sums. So integral x squared dx plus integral, okay, 1 by 4 is common, right? 1 by 4 integral dx minus integral x dx. Okay, so this will get you x cubed by 3 plus integral dx is x, right? So you'll have x by 4 minus integral x dx is x square by 2. So I hope this sum is clear. Now some homework sums. Question number 1, integral root over x dx. Number 2, integral 1 by root over x dx. Number 3, integral 4 e to the power x dx. Number 4, integral x cube dx. Now this is a definite integral sum. So your limit is from 1 to 2. Number 5, integral u to v mv dv. M is the mass, m is a constant here. Okay. Now this question number 5 is a derivation from work energy power chapter. That is probably chapter number 6, I believe. Chapter number 6, class 11. Okay, so I'm solving this now, but I would suggest you to try solving them by your own, and then only go through the solutions. Don't jump into the solutions initially, otherwise you will not know how they work. So number 1, integral root over x dx. So root over x is integral x to the power half, right? X to the power n plus 1 n plus 1 divided by n plus 1. So x to the power 3 by 2 divided by 3 by 2. This gets you 2 by 3 x to the power 3 by 2. Now x to the power 3 by 2 can be written as x root over x. That's your answer. Next question, number 2. Integral 1 by root over x dx. Okay, so integral x to the power minus half we can write. Yes. So x to the power minus half plus 1 divided by minus half plus 1. So this gives you x to the power half divided by half. So your answer is 2 root over x. Next question, number 3, integral 4 e to the power x. I hope you are understanding the sums. So 4 taken common, integral e to the power x dx. So integral e to the power x dx will get you e to the power x only. So this is your answer, number 4. Integral, limit is from 1 to 2, integral x cube dx. So integral x cube dx gives us x to the power 4 by 4, and the upper and lower limits are like 2 and 1. Okay, so now you put these limits in place of x. Yes, so once you will put 2, so it will become 2 to the power 4 by 4 minus, because you do upper limit minus lower limit, right? So in place of x again 1 to the power 4 by 4. So see how we write 2 to the power 4 divided by 4 minus 1 to the power 4 divided by 4. So this is 16 by 4 minus 1 by 4. So what you have is 15 by 4 as the answer. And the last homework sum, that was number 5. Yes, number 5. Integral u to v mv dv. So m taken common, m is a constant here, right? V dv, limit is from u to v. So integral x dx is x square by 2. So integral v dv will get you v square by 2. So m v square by 2, and you put the limits here. Now we'll place the limits or use the limits, upper limit. So in place of v, you are using v. So v square by 2 minus. Now you are using the lower limit. So in place of v, you are using u. So it becomes v square by u minus u square by u, right? So half, it's just a rearrangement. Okay, mv square minus mu square. So even if you do till the second last step, you are correct. You are very correct. Okay, so thank you so much. Have a great time. We'll meet in the next lecture. Okay, thank you.